Hi there, how are you doing today? Let's talk about dependency injection in the next 10-ish minutes. I plan to do this in 2 videos. This is the first one that I'm going to talk about dependency injection without any specific technique related to C# or .NET Core or .NET in that sense. All those concepts of dependency injection, all kinds of things, you can apply that anywhere for any language that supports it. The second video is going to be everything about dependency injections in C# and .NET Core. Let's dive in. Let's take a look at the code architecture. The primary class that we're going to look into today is a doc report. It had one method to print a doc info in form of JSON. And we also have a POCO class named doc to contain properties like name and breed and weight of a doc. Here's how the doc class looks like. And this is a doc report. The print method takes in doc object, serializes it to JSON, and prints it. Now let's talk about dependency injection. Firstly, what is a dependency injection? To understand that, we need to define what is a dependency. A dependency is actually a class relying on another class. For example, doc report relies on doc class to provide the doc info. That we say a doc report have a dependency of doc. On this doc report class, how many other dependencies are here? On line 10, we rely on the JSON convert class to serialize the doc object. On line 11, we rely on console to output the text. And those are the 2 other dependencies. Now that we know what is a dependency, then what is an injection? It is actually very simple. If the dependency is passed in, we call it injected. In this class, doc is passed in, so we say the doc is injected. On the contrast, the JSON convert and the console are not. Okay, now that we know what a dependency injection is, we're going to ask ourselves, why do we want to use it? In other words, what are the benefits? Well, let's have a discussion. I think the first benefit is that it makes the relationship in between classes explicit. For example, at the beginning, we recognize there are 2 types in the doc report service. And with the effort of reading the implementations, we know there are actually 4. And the reason we missed JSON convert class and the console class is that when we take a glance at the print method, we didn't see them. Now let's go back and change the code to use dependency injection for the JSON convert, and let's see how it will look like. Since JSON convert class is a static class, I'm creating an interface for abstraction. Since we only care about serialize an object to a JSON string, I'm going to create only one method that takes in an object and returns a string. With regarding the implementation, I'm just going to call JSON convert here. I'm putting the class and the interface in the same place just for the ease of the demo, but usually it's always recommended to put everything, one class or one interface in one file. Let's go back and make an injection in the doc report. Instead of calling into JSON convert class directly, we are relying on a dependency called iSerializer. If I'm asked again, well, what's the dependencies for doc report? I think I can easily tell at least doc and the serializer, because those are injected and they are explicit. And when debugging a complex system, it is very important to see the whole picture. And dependency injection makes that easy. Let's finish the code and making sure it still runs. I'll set up some breakpoint and run the debug session to show you like the serialization still happens. Now let me hover over the doc.json and let's see the result. That's the first benefit, explicit. The second benefit actually relies a little bit on the abstraction part. It is decouple. As you can see, in the last example, we abstracted the serializer. That decouples the classes of DocReport and the serializer. And why is that a benefit? Let's say if we have a newer serializer which performs better, we can make use of it without changing the class of DocReport. And the less we change our code, the less of chance for us to make a mistake and introduce new bugs. To demonstrate that, let me throw in another implementation for the JSON serializer. This serializer 2 implements the exact same interface of iSerializer. Instead of using Newtonsoft JSON convert, we're going to use text JSON. Since they implement the same iSerializer interface, they are interchangeable. So what I'm going to do is, here I'm going to inject serializer 2 to replace the original serializer 1. And I'll start debugging just to making sure it still works. Let's see that serializer 2 is injected. And the serialization of a doc still happens correctly. Okay, now benefit 3, better testability. Well, this example is also built on the fact that we have a better abstraction. Let's think about how can we unit test the output. The challenge here is the result will be output directly to the console. And intercept the output of the console is usually flaky at the best. So to address that challenge, we can abstract the console. Let me show you what I mean. As you may guess already, what I'm going to do is I'm going to create an interface for outputter. It will have a method to take in a string for outputting and returns void, just like the writeLine method on the console class. Only this time I'm going to write the concrete class first, and then go ahead and extract an interface of it. Oh, by the way, this trick is very useful, and you can do it in VS Code or Visual Studio. Now we have the concrete class, and we have an interface. Let me make the interface a little bit more generic. It's time for us to update the code in the DocReport to make this injectable. Instead of calling console.writeLine directly here, let's rely on the injected dependency. Of course, we need to update the caller to do the injection. Now if we run the code directly, since the console output still calls console, the functionality of our code won't be changed. However, remember, our DocReport do not rely on console directly anymore. It relies on iOutputter. And that's where we can throw in a mark of the outputter for result inspection. To demo that, let's take a look at the unit test. Firstly, I'll build a mark of the outputter. When writeLine is called on this mark with a value, instead of outputted to a console or something like that, I'm going to save it to a public property. Convert it to an expression to save some space. Now let's look at how to use it. Let's print a doc. Well, actually, it doesn't matter which serializer to use. And with regarding the outputter, we're going to use an instance of this mark outputter. Actually, we can do two outputs, one from the serializer 1, another from serializer 2. And if the serializers works exactly the same way, they should have the same output. Now let's see if o1.value equals v2.value. Let me set a breakpoint here and start the debugging. As you can see, both O1 and O2 hold the output value that we can test on. Whoops, the test actually fails. This is great. Not only we make the code testable, we actually catch a bug. Let's focus on the topic for a while. I'll show you what failed the unit test later. That is the third benefit of the dependency injection, that it enhanced the testability. Let's do a quick recap. We talked about what is dependency, or what is injection. Based on the understanding of what the dependency injection is, we went through 3 benefits of using dependency injections. They are explicit, decoupling, and testability. Well, thanks for watching. I hope you enjoyed it. If you like the content, please don't forget to like and subscribe. Now, let's take a look at what went wrong. The different serializers handles the numbers slightly different. Isn't this the gap in between the ideal world and the reality? Alright, that's it for now. I'll see you in the next video. Until then, take care.